Okay, so let's get into NAT for IPv4. Um, so this is getting into chapter 6 for our CCNA. So off we go. So NAT is short for Network Address Translation. We use NAT pretty much in every single day. NAT is utilized as our primary method of separating our internal private networks from basically the rest of the internet or WAN, so public addresses. So NAT was originally developed because we started to run out of IPv4 addresses. And so the primary goal of what NAT does is it allowed us to kind of separate our IP addresses into private and public ranges and utilize a set range of public addresses for global intercommunication, and then have a set chunk of internal private addresses that anyone could utilize. And there's different types of NAT translations that we can essentially do as well. So we have static NAT, dynamic NAT, and also PAT. Um, and then we also have NAT for IPv6 as well, though NAT for IPv6 is not exactly needed right now. Um, but there is a form of NAT that can be used for allowing intercommunication between IPv4 to IPv6, and that's known as NAT64. And we'll get into it a little bit more. So looking at what NAT does, so like I said, NAT was developed in order to basically increase the duration for which we could utilize IPv4. It was essentially a temporary solution for solving private and public, or solving kind of the shortage of IPv4 addresses by creating private and public addresses. So our private ranges that we are typically should know about are broken up into three classes: Class A, Class B, and Class C networks. So these ranges that you see are private address ranges that we can use. And so 10.0.0.0/8, 172.16.0.0/12, or 192.168.0.0/16. So those are three private ranges. So anything that exists within those three ranges are considered private address scopes. Everything outside of those ranges are in the public address range. And so that can be like an address that you might get from, say, your internet service providers, such as, say, Comcast or, CenturyLink. So NAT creates a translation of that private address range to a public address. And it's pretty cool what it does, and how it essentially works. Uh, so how it's translating the address, if we look at, say, what our router does. So if we take look at a router, and we have it, say, go out to the internet here. Nope. That's it. That's the internet. Um, and then we have our internal network as well on our PC. And let's say that our internal network was at something like 192.168, 10.0, and it's a /24. So my PC, I'd have, say, like a .10, and my gateway for, say, this interface is, say, the G00, and it'd be at, say, like a .1 IP address, so 192.168.10.1. And then we'd have our external link out, and so this might be a serial connection, so say serial 00. And so for this type of connection, we might see something like, it might have a public address of, say, like 209, 0.10.1, and who knows where it's going out to the internet. So this address, that 209 address that I am assigned right there, that is the address that's given to me by my internet service provider, my ISP. My internal range that I utilize, that can be anything that I want as long as it falls within the class A, B, or C ranges. So when my machine wants to go out to, say, uh, a server, such as, say, Reddit, right? When I want to go out to reddit.com, I open up a browser. And how that works is that my internal address, this is not a routable address across the LAN. This is a private range that only works within my private area. So if I'm trying to route across the WAN, going across the internet, that doesn't work by utilizing this 192. So again, I would say, I'm gonna, oops, scroll out here. So if I'm, say, looking at my frame, when my frame is being built and being sent out, when I go out to reddit.com, remember it has the data section, then it has, our layer 4 header, so whether it's TCP or UDP, and then it has our layer 3 header and our layer 2 header. So remember, in our layer 3 header, that has a source and a destination IP address. So my source IP address would be my IP of my PC, my internal IP address of 192.168.10.10. So I'm just going to be a little lazy there. And then Reddit is going to have an IP address of, say, I think Reddit's at like 151, 101, 53, 140 is its actual IP address. So that would be the IP address. So I'm just going to be kind of shorthand it and just write the last two octets. So .53.140 there. And so that's the IP address. Now, this is the public IP address of Reddit. So this is its forward-facing address. Now, Reddit is very large, so it has more than one public IP address. This is just one of them that I'm utilizing to communicate to their systems. So I've built my layer 3 header, and then my layer 2 header, remember, also has a source and a destination, but these are for MAC addresses. And remember, my MAC address for this is that it'd be, say, like my server has, or my PC has, I'm a shorthand MAC address of AA, and then my gateway would have, say, a MAC address of, BB. So source would be AA there, and destination would be BBB. So when that frame gets sent out and it gets goes up to the router, remember what the router does with it is it strips off, it receives the frame, and because this is encapsulated, it has to strip off the layer 2 header in order to be able to read the layer 3 header. And what it does is it looks at the destination address and it goes, okay, well, do I know where that address is? Let's assume the answer is yes, which is it knows to forward it out towards our ISP to get to reddit.com. But before it can do that, it understands that, hey, this is not the source address is not a routable address on the internet. So what it will do is it will translate and use, typically this is what happens for most home networks, is it will translate our private address into the public address that exists on that interface serial 00 there, that 209.010.1. And what it will do is it will hold that NAT translation in a kind of a short-term table, so that when my frame gets translated and gets sent out and goes all the way to Reddit, when it comes back, it remembers that it made that translation and is able to retranslate it back. So what happens when that frame gets rebuilt and gets sent back out, makes its forwarding process. Remember, the layer 2 header changes, but the layer 3 header will also slightly change as well when that frame is being sent out towards from PC, my internal PC, out to reddit.com. So remember the destination address right there stays the same at 53.140, because that's still a public address, but my source gets changed from 10.10 into the 209 address, .0.10.1. And then, my layer 4 info is the same, and my data section is still the same as well. That doesn't get changed as we're kind of working with that. But that's essentially what NAT does, is it's changing up the source address of the layer 3 header and translating it into a different way. And we have different ways that we can do this. So a couple of things that we can do when we're looking at NAT is we have 3 different methods. We have what's known as static NAT. We have, oops, didn't mean to make an O there. Dynamic NAT. And we also have PAT. And there's actually a 4th option as well called dynamic PAT. So what these 4 options are is static NAT is one-to-one translation. So it takes one private IP address or one private address and translates it to one public address. So if I have, say, like an internal server or web host that I have that I'm going to allow, say, traffic from the internet to call out to, I can have a one-to-one mapping between those two things. And so static NAT is very common. We want static NAT for web hosting. So that's what you'll see for that. Now, dynamic NAT is what's known as many-to-many. But the problem with this is that dynamic NAT essentially works similar in essence to DHCP, where we're given a pool of public IP addresses. So I might have, say, like a pool of 5 public addresses. But that means that I can only map at any given time 5 private addresses between these two systems, or between those areas. So only 5 private machines, 5 PCs, can go out to the internet at any given time. So if I have more than that, then those systems have to sit and wait, and they won't be able to actually go out towards the internet until someone else is done. Now, the nice thing about this, though, is that it's not like static. So any system can go out and borrow one of those 5 public addresses, and they're very short term. So as soon as someone's done, it frees up the pool. That works. You don't typically see dynamic NAT utilized in the real world. It's not very frequent. However, a version of it is, which is dynamic PAT. PAT is a one-to-many or if you want to call it, sorry, it's more of a easier way of saying it is it's many to one. So what PAT does is it's essentially a more advanced form of NAT. This is what you typically see for, say, like your home networks. And what this will do is it still does the exact same thing of allowing translations to occur on any system. So any internal system can utilize it. So it's kind of similar in essence to dynamic NAT. But what it will do is, this is kind of what I've explained here, is it will translate to the public address that you are given by your ISP. And that's what we're allowing here. So PAT utilizes what's known as port address translation. So if I have, say, multiple systems that are, it's want to go out to the internet, both of them can utilize the same public IP address, but remember, they also make some modifications into, say, that layer 3 header and the layer 4 header, which is looking at our source and destination ports. And so what PAT does is it will make some modifications to the source port, and it will change it up, and it will just say count up, and it'll say, like, right, the source port, it will make a mapping of, say, well, my port before was, 5,500, and it will make a map between those two things and kind of remember, okay, this system called out on 5,500, and my router will remember those port numbers. Now, if another device comes out and it's also using 5, our PC at .20 here was also using, somehow pulled the exact same port, then our router is actually smart enough to go, well, okay, well, I already have a dynamic mapping for that one, so I'm going to make a slight change to the source port that I'm changing it to. And so instead of being 5,500, I'll just count up. So it's 5,501. And it'll make an adjustment so that there's not when, if they're both these systems are going out to Reddit and Reddit goes, well, hey, I just got 2 requests to go to the same place from 209.010.1 on the same source port. I'm going to drop one. Instead of having that kind of overlap to occur, our router makes the slight change for us so that when the return traffic is trying to come back and through, our router understands, oh, okay, or Reddit also understands, okay, there's a different port. These are for 2 different things. So it's not an overlap, it's not a duplicate packet. And our router keeps track of those translations that occur in a table and is able to retranslate that traffic back down and through. So it works pretty well. And then we also have dynamic PAT, which is also a version of kind of dynamic NAT, where it's many to many. But what this allows us to do is, it's basically, it utilizes PAT, but I might have, say, something like, 2 public addresses and, say, like 200 users or 200 private addresses. So what dynamic PAT does is essentially it's a form of load balancing for our internal systems, so that we're not all trying to utilize that exact same single public IP address. And it allows those addresses to kind of be split up between the number of public addresses that I actually have. So this is good. You'll see dynamic PAT for very larger scale organizations and kind of networks. But for typical home networks, PAT is what you typically see on an everyday basis. So that's kind of the general gist of kind of getting into PAT and NAT, different methods that we use. There are some key terminology that we need to know in NAT that you'll see. So NAT looks at 4 different types of address messages, and this is the proper terminology, which is inside local, inside global, outside local, and outside global. So what does this terminology actually mean? An inside address just means that it's the internal private address. So if you see inside local, it's just talking about your internal private address that's going to be translated by NAT. Um, Outside address, that's the destination. So that's where you're trying to get to. Um, and a local address just means private, it's your internal side. And a global address just means public, it's the public facing side. So um, that these terminology can sometimes be a little bit confusing. So hopefully it doesn't get you caught up too much. But really just remember if you see inside local, it's private. If you see global, it's public. That's all that means. So when we're looking at the actual terminology that you'll see from, say, a routing table, so a NAT translation table, our NAT translation table has 4 columns that's going to be associated with it. It has an inside global address, an inside local address, a outside local address, and an outside global address. So again, all this means when we're kind of looking at this, really the primary things that you just have to understand and note with NAT is that I will the addresses that we see is the inside global address. That's our public address. So if I'm sitting on my network, in my PC right here, the inside global address is the public facing IP address for my network. My inside local address is my private IP address, the address of my actual system that I'm sitting on, my private IP. And because this is not a routable address, it has to translate into the inside global address, so the public. And then the outside local and outside global, they're a little less important. Essentially, the way, because of how NAT works, I will never know what the internal network scheme actually is for any other network besides my own. And that's fine. I don't need to know it, and I don't really care to know it. But because I don't know what it is, your outside local address and your outside global address is always going to be the public address of the destination of where you're attempting to go to. So really, they're less important in terms of kind of knowing, besides the fact that if they will both be the exact same address, because it's the public address of the destination that you're attempting to go to. So, like, again, if it was, say, like Reddit that I was attempting to go to, my both the outside local and the outside global would be that 151, 101, 53, 140 address. And that's fine. So we talked about our types of NAT. So we have static NAT. Static NAT's very, very useful for doing a one-to-one translation, typically for web servers. We talked about dynamic NAT. It utilizes a pool of public addresses that maps to private, but again, we don't typically see it too frequently. PAT is pretty much the most common way that it utilizes. Again, it will make translations and mapping between not just a internal IP address and then our private IP address and our public IP address, but it'll also record port numbers as well for the translations, so that we can have multiple systems at the exact same time utilize the same public facing IP address. This is what we use almost all the time if you're using IPv4. Again, like I said, NatPat is going to try and use the exact same original source port, but if that's already being utilized by another one, it will just increment itself up as it goes through. So typically we use PAT. So kind of moving on, let's kind of look at some like pros and cons of NAT. Benefits of NAT, again, conserves address space, which is very much needed for IPv4. Allows us to have multiple addresses or multiple systems go out on one single public address. So cost savings benefit right there. Um, pretty flexible. And it does actually provide a certain layer of security through obscurity because it hides all of our internal network scheme through one forward-facing address, typically. So that's kind of cool as well. Drawbacks, though, uh, there is some additional overhead because I have to translate every single frame that goes out towards the internet. That's going to cause a lot of additional overhead. So we have to make sure that we plan for a router that can handle the amount of throughput and traffic that's going to have to be processed. Um, Not that big of a deal for most days in most scenarios, but it is something you have to kind of think about. Um, the biggest issue, one of the things that we have to kind of think about is that we do lose full end-to-end point connectivity. And so what I mean by that is the furthest point I can see if I ping out to, again, say like Reddit or Facebook or, Google, is I can see all the way up to their forward facing address, and I can't see any further than that. So if I wanted to actually ping the physical server that I'm trying to attempt to go to, that's not something I can typically do. Um, I Once it hits their router or firewall device, that's I can only see up to basically their forward-facing router or firewall. Um, so I can't see inside of their actual network. So kind of think of it like a house. If I look at my neighbor's house, um, I can see that there's a house there. I can see how far away the house is, but I can't see into the house. But for this point, I can see is their door, and so that's kind of the same idea. Um, Other things, NAT does actually cause some additional complications with tunneling. So uh, this can actually be a pretty big issue if you're trying to say set up a VPN between multiple different organizations. So, if I'm trying to set up a VPN from, company A and we're doing some contracting work with company B, and there's an overlap on private address schemes between the two, that can be a bit of an issue. NAT can sometimes it can just make VPNs sometimes a little trickier from a business perspective. So static NAT, we're going to kind of move into just like how to kind of configure it. Now, one thing to remember is I do have all these commands already posted up in our class, so make sure that you go through and check them out. But I'll run through them pretty quickly. So for configuring static NAT, it's pretty straightforward. There's really kind of just two steps. The first step is you just make your translation. So you tell it what mapping you're creating by saying IPNAT inside source static, and then the private address that you're going to map, and then the public address you're mapping it to. So in this case, they're mapping it to 192.168.10.254 is their private, and the public address they're mapping it to is 209.165.201.5. Now, the important thing to note here on the router is that public address doesn't have to exist on any actual interface. It just has to be present. So that's one thing to kind of note. But it's good to make sure that that address typically is in the range of public addresses that are provided to you. So more times than not, an organization will, if I need in the real world, if I need like two public IP addresses, my internet, I'll purchase them from my ISP, and my ISP will give me a small /30 subnet. And it'll say, okay, here's your 2 public IP addresses that you use. And I can use one for static and one for PAT. And then on my, or they'll, make it a small, like a /28 or /29, depending on how many addresses I actually need. So we set up so that is the command to actually configure it. And then to actually apply it, we go into our interfaces that we have. And on the internal facing network, we'll say IPNAT inside. And on our external facing, our public facing interface, we'll say IPNAT outside. So all this is doing is, if we're kind of looking at it, is I'm just going into these interfaces, say S000, and I'm saying, oops, that's the outside or public face of my network. And this is the inside, which is my private side of my network. So I'm just defining, so the IPNAT inside and IPNAT outside are just defining, this is the public side of my router, this is the private side of my router. Now, you have to do these commands if you want to actually turn NAT on. So I can configure NAT, but until I actually apply IPNAT inside and outside, NAT will not work. So for verifying it, a very good command that we can utilize is the show IPNAT translations command. So what this will do is it will show us if we have our current static, if we have a static translation, it'll show us what our static map actually is. And then once I actually send traffic through that router going from my internal side out to the public side, then you'll actually see a translation actually occur in the NAT translations. Now, one thing to note is that the table does kind of only holds data for a short period of time. So roughly about, say, like 10 to 15 seconds, give or take. So after that X amount of time, it does clear its table. So you do have to be kind of quick if you want to show those translations. So it only holds the translations while they're actively being utilized, and then for a short period of time afterwards. Show IPNAT statistics, also very useful as well. It can kind of show you any active translations that are occurring, the number of addresses that might exist in a pool if you're using, say, dynamic NAT, and the number of addresses that have been allocated towards systems that need that pool. So dynamic NAT, for creating dynamic NAT, it's similar in essence to kind of setting up DHCP. But instead of saying IP DHCP pool and then the pool name, instead what we use is we say IP NAT pool and then the pool name that we create. And then we specify the range of addresses that we're going to be allowing to be translated. So what the pool actually is, and this is our public facing side of the pool, and then the net mask and how big it is. And then we create an access list. This is a permit only access list that permits the range of private addresses that we're going to be allowed to use the pool. So step 1 is create the pool of public addresses that we have. Step 2 is create an access list that says, here's the private addresses that can use the pool. And then step 3 is binding the access list to the pool. And this basically says anything that comes from the 192.168/16 address can translate to that 209 pool that I've created. And so with that, we use that IPNAT inside source list 1, which calls access list 1, and then pool, and then we call the NAT pool that we created in step 1. And then the final step for dynamic NAT is similar to what we do in static NAT. In fact, you have to do this for any form of NAT that you're using, which is define the inside and outside, so private and public sides of our router. So verifying it, similar methods. So we're going to kind of move into PAT here. And this will kind of be the last little bit. So PAT is great. We have a couple different ways that we can set up PAT. Really, it's very similar in essence to how we set up, how we write our ACL. But the key word that basically turns PAT on is the word overload. So overload is PAT. So overload is the command that we use to say, hey, we're going to be utilizing PAT, so make sure that you're mapping and also keeping track of the port numbers in the NAT table as well, not just the IP addresses. So again, this is probably the most common way that we see PAT. So for actually configuring it, it's very similar in essence, but essentially what we do is we have a couple different methods of how we can do it. Easiest way that I've kind of typically used PAT for creation is we create our access list. They kind of did this out of order. So you should do your access list first, and you permit what you're permitting is similar to what we did in dynamic NAT, where we're stating the private addresses that are allowed to be translated. So access list 1 permit 192.168.0.0/16. And then we're specifying, then we're binding it to, instead of a pool, we're binding it to an interface that we're going to be allowed to translate to. And so with that command, it's IPNAT inside source list 1, which calls access list 1. And then we use interface serial 010 or whatever interface of where you want the NAT translations to occur, and then the overload command. So if we look at our kind of topo here and what I've been kind of writing out, the interface of if we wanted our internal machines to be able to translate using PAT, we would specify interface serial 00 and then overload, and any system on this internal network of 10.0/24 would translate to this 209.0.10.1 address. So we'd be specifying where you want the translation to occur. And so the interface is always going to be the public facing interface for our devices. So I think that's pretty good for kind of going over the different modes of PAT, NAT, static NAT, dynamic NAT. So yeah, if you have questions on things, feel free to reach out. Otherwise, hope you have a good day. Bye.